to that story now. A new study traces all our roots to Botswana. The landmark study based on DNA evidence has found that the homeland of all modern humans is the south of the Zambezi River. It says climate change forced our ancestors to migrate. For more on this, author of this very study, Professor Vanessa Hayes, is from the Garvan Institute of Medical Research in Sydney, Australia, and she joins me now from that country. Good morning, Prof. What does this study reveal exactly? Because some are under the impression that the origins of humanity, they come from here in this country, South Africa, where I am.
Well, good morning, South Africa. Well, actually, South Africa played a very important role in the study. So, so how we did the study was it was based on part of the DNA that we inherit actually from our mums. And it's a study that's taken a very long time, but we were able to trace using this lineages that we find in the DNA, the ancestral code, we could trace our ancestral roots to an area south of the Zambezi, which would have stretched from Namibia across the northern part of Botswana into Zimbabwe as the Okavango-Machali region. And the reason that we could really narrow it down to this region was we overlaid the genetic data with geographical data and climate data. And that really pinpointed this region. It's actually a very, very large region.
So talk to us about the conditions that would have forced these early humans then to migrate to Botswana. Where did they come from originally? Because I think people are going to be quite interested to learn how does or where does South Africa come into this picture?
Okay, we can really talk to that. So first of all, in the study, we're actually only looking at living modern humans. So we don't actually go beyond the 200,000 years because we're only looking at people living today. So we didn't use archaeological data, fossil data, in other words, DNA from skeletons and people that have gone extinct. So that's the one message. We then discovered that this Machali area, I mean, as you all know, if you've been to Botswana, you'll see all the salt pans, that this area was once a very large lake, which by the time our modern human ancestors are living in the area 200,000 years ago, it had already started to break up due to the tectonic faults under the land. And so it would have been a wetland, so little lakes all the way around the region, something like the Okavango Delta looks today, which is ideal for human life. What we then saw was that our ancestors appeared to stay there and thrive there for 70,000 years before they migrate out. And what we saw through the climate data was that southern Africa was in a mega drought. And this Machali area was an oasis, ideal for human habitation. So how did that change, and how does South Africa fit into the story? Well, we saw that at 130,000 years ago to 110,000 years ago, we see migration. We can see that in DNA. We see people start moving around, first to the northeast and then to the southwest. And that matched almost exactly with climate data. First in the northeast, it becomes humid, which would open up corridors of vegetation, which actually allowed people to leave. In the southwest, that only happened at 110,000 years ago. And so some of our early ancestors decided to explore. And we can see that these explorers did extremely well, and technically they are the first South Africans. They migrated all the way down through Namibia and all the way along the south coast of the country. And we also know that through archaeological data at Bloemhouse Caves that have very, very rich data showing cognitive, so in other words, human behavior of art and jewelry, orca making, that modern humans were very productive at the southern tip of Africa, more than anywhere else in the world.
Wow.
And so our genetic data is supported by the archaeological data, as well as the climate data.
Wow.
And I think this is extremely exciting for South Africans.
All right. Well, thank you very much, Prof, for those insights and explaining that to us so well. Professor Vanessa Hayes is from the Garvan Institute of Medical Research in Sydney, Australia.